Hi, my name is Sahas Kurumety, and today I'll be showing my model of N95 masks in poor air quality areas. And this was created using a simulation in the Comsol multi-physics engine and utilizes the concepts of mass transport. So the significance of this is that N95 masks have become very popular and well known in the public over the past 1 to 2 years. And this is because of their use in the COVID-19 pandemic, where they were used to help prevent people from being exposed to the virus. However, these masks are also designed to help prevent people from getting sick from pollution from factories or cities with smog as well. So it'll be interesting to see how the mask actually reacts to soot and ash in this setting. So here you can see the setup that I used for the simulation. And on the left, I had a pocket of contaminated air contaminated with soot. And in between, I had a millimeter thick mask layer. And on the right was a pocket of fresh air. And what this aimed to do was to see how the contaminated air was able to seep through the mask and get into the fresh air. And listed below are some of the assumptions, including the diffusion coefficient of the soot into the air, the concentration of the soot, which I used the concentration outside of a factory or in a very, very poor air quality environment. And I also assumed that no diffusion was leaving the system just to make things a little simpler. And in addition, I found properties of the N95 masks that had to be plugged in to their own material in the Comsol engine. And one thing to note is that the porosity actually does change with the size of the particle going through it. So I used the porosity for a mid-sized particle, which was soot. So at the top here is the actual simulation itself. And this was done by testing times from t equals 0 seconds to 120 seconds at 2-second increments. And to note is the concentration on the complete left side was held steady at 5 times 10 to the negative 7th moles per meters cubed. And in addition, you can see in the simulation that the mask slows down and prevents some of the particles from getting through. However, over longer periods of time, it does get contaminated in the fresh air section. So some of the key takeaways from the simulation is that the mask is fairly effective at reducing the contaminant exposure. However, after longer periods of time, the soot does manage to get through. So what we can infer from this is that N95 masks should be used in these settings, and it's definitely better than not wearing one. However, ideally, people should try to avoid these low air quality areas where they would be exposed. So there are a couple ways that this simulation can actually be improved in the future. And the first is to account for the different layers of the N95 mask. So the N95 mask is actually made of 4 different layers. And it would be interesting to see how the particles actually react with each of these different layers rather than averaging them all together. And the second would be to simulate contaminants of different sizes, because the diffusivity of the particles actually does depend on the size of the particle. So it'd be interesting to see smaller particles and then larger particles and compare them. And the final way would be to account for airflow around the mask when it's worn improperly, because in the real world, not everyone is always getting that airtight seal that is in ideal condition. Thank you for watching. I hope you learned a little bit about mass transport and N95 masks. And just a disclaimer that this video was created solely for educational purposes.